Namaste, Namaskaram, everyone. It's me, Jay, and I'm very thrilled and glad to welcome all of you in this 27 series of Tech Webinar. So, Tech Webinar Nepal is an online platform where we conduct technical stuffs, technical session related to the technical stacks. So, first of all, I want to thanks to all the member of Tech Webinar to support the series till 27, and thanks for all your enthusiastic. So today we are going to conduct a session on art of simplicity in programming by Dr. Venkat. So Dr. Venkat Subramaniam is an founder of Agile Developer, and he is a professor at University of Houston. So thank you, Venkat sir, for the invitation. So with this, so we would like to move with our speaker session. So the floor is yours, sir.
So let's get started. Well, we all carry with us something enormously, I should say, capable. That is the human brain, if you really think about it. The human brain is probably one of the most capable things in the world. And it's one of the things that really intrigues and fascinates me because we have this ability to be absolutely creative. And yet at the same time, we also face that challenge of the analysis paralysis, the emotions that come into the picture, where we get confused, we get tangled up in ideas. How do we really cope up with some of those things? Well, it turns out that one of the things I remember very fondly talking to my children quite a bit along the way was about Schrodinger's cat. Well, Schrodinger ran a thought experiment. There was a box through which you cannot hear or see, and through this box was, within the box was a cat. And of course, there was a vial, so at any given time, the vial could break and the cat could get killed. There was no way to know at any given time whether the cat was alive or dead. And his hypothesis was at any given time, the cat is both alive and dead. And we talk about Schrodinger's cat among my children quite often, but one of the things that intrigues me is about simplicity, and I have a feeling that simplicity is Schrodinger's cat. Well, we'll get back to that later. When it comes to simplicity, the question I want to start with is, Confucius said, life is really simple, but we insist on making it complicated, he said. So I want to start with the question as to why. Why do we want to make things complicated? Well, I'll be honest about it, and I hope you will be too. We like to make things complicated because, let's be honest about it, right? It feels good. It feels good to make things complicated, isn't it? Which is kind of sad. Why? Because we feel like we are worthwhile something when we create something complex. You show a design to a colleague. The design is fairly simple. It does the work. And your colleague looks at it and says, yeah, it makes sense. It's working. Good job. That's pretty simple. And you feel a little let down, isn't it? You're like, let me come back tomorrow. And we want to make it complicated and go back to them. And because that makes us feel good. And in fact, I would say, go to companies and see what happens. When companies hire interns from college and they come and spend the time in the summer working with the company, don't send them away. Go back with them and see what they say. They probably say, the people I worked with in the summer, they are genius because I understood nothing of what they are doing, right? So we have this kind of feeling that something that's complex is more credible, but unfortunately, that's not true. As Einstein said, any intelligent fool can make things bigger, more complex, or more violent. It takes a touch of genius and a lot of courage to move in the opposite direction. And the most important word I want to underline here is that word courage. It actually takes courage for us to stand up and say, no, I'm not going to make this complex. I'm going to work towards making this simple. And there's going to be pressure every single way, if you will, where people will try to force us to make things more complex and more violent, if you will. But it really takes us a courage to stand up and say, no, I'm going to work towards simplicity. But the question is, why is it really hard to make things simple? And part of the reason for that is, if simple was sitting next to you on a train or a bus, would you know, hey, you are simple? That's what simplicity is, right? Well, we don't know what simple really is. If you ask people if that should be simple or complex, they always will tell you, of course, it's got to be simple. But how do we really make things simple? And this reminds me of an experience I had with a group of developers, and I was reviewing the code and I was saying, my goodness, this code is complex. And one other person eventually said, hey, you keep saying this code is complex, but we collectively, as the programmers who wrote this code, think that it is simple. Why do you say it's complex? The developer asked. And that's when I realized we don't even know what simple really means. We all kind of know that things should be simple, but how do we really know that things are actually simple? And that's one of the problems that we have to deal with constantly, is that simplicity, and how do we even recognize simplicity? So what is really simple and what's not really simple? As it turns out, it's not really that easy to answer what is simple. So maybe I'll take an opposite approach. I'll talk about what is not simple. And maybe if we can identify what's not simple, we can avoid those and maybe hope that what's left is actually simple. So let's talk about a few things that are not simple. The first one is simple is not clever. Now, let's be honest about it. Let me ask you this question. Have you ever written a clever code? Well, we all have written clever code, isn't it? We all write clever code because it feels really good. You go home and tell your parents, you know, I wrote this code and nobody understood it. And they pat you in the back and say, I know you're going to grow up to be a big person one day. Absolutely. We take pride in creating clever code. Well, unfortunately, though, the more clever the code we create, the harder it is to understand it, to maintain it, and it comes back to haunt us. This reminds me of an experience I would never forget. I had written a piece of code, and of course, a few weeks later, the client wanted to make a change. And I looked at it and said, I could make this change in 10 minutes, but I don't want to make this change. I want to make the mother of all changes. So I went and made a clever solution, and I had this beautiful experience. I was so glad I patted myself in the back. Well, a few weeks later, of course, we found a major problem in production. And the problem really came from the cleverness of my solution. I learned my lesson the hard way. These days, when my mind tells me create a clever code, I delete it and start over. I want to create a clear code, not a clever code. But let's look at some examples. Notice what you see up here, and you may immediately recognize what this is. Yes, that is the enum definition in Java. So you have public abstract class enum. Let's walk through that. Enum E extends enum E. Let that sink in a little bit. Oh yes, that noise you just heard, that's your brain throwing an exception. Now, this code is a real code from Java, but it is enormously complex, isn't it? And you kind of wonder, why would enum E extend enum E? That seems like a recursive call. Would it even work? Well, sure, it does actually. Now, of course, one of the things I often talk about programmers is they ask me, how do I obfuscate my code so others don't understand it? And I always tell them, why do you need an obfuscation tool? Your programmers create self-obfuscated code already. They themselves cannot understand the code after a few weeks, after all. So this reminds me of a few different examples I've seen over time. I came across this gem. Notice it says float in square root and then float x. Now, don't ask me what x means. I have no clue what x means. But here's the good news. Whatever x is, we now have half of it. Then, of course, notice the next line after that. We have a star parenthesis int star ampersand x. Of course, we are supposed to know what that is, right? And only gets better in the next line. But here's the beautiful thing. It doesn't matter what's all happening. This function eventually returns an x. How do you understand what all these code is doing? Oh, and remember how they told us the code in object-oriented programming models the real world. Well, somebody took that to the heart and was creating a program for flight simulator and decided to write the code like this. Now, my question oftentimes is, when I see code like this, I often ask people, where were the adults? Where were they leaving the children to write code and walk away? So we definitely want to be careful about writing code in a way it is clear and not very clever. So I said that simplicity is not clever. Well, simplicity is not necessarily familiar. And I want to really take the time and to emphasize this one point. When I program with developers, when they come across something new, they often say, oh my gosh, it's complex. And I always pause and ask them to confirm one thing. Is it complex, or are you telling me you're not familiar with it? And this is something we need to keep in mind very clearly, because it's easy to get confused over time. So think about the two words familiar versus the word simple. So sometimes we use the word that is simple, but what we really mean is that it's familiar and not simple. We humans have this nature to use the word simple to mean what is familiar. And we have to be very careful in making that decision. For example, if I show you that and I ask you, what is that? You might be able to answer it, or you might not be able to answer it. You might look at this and say, oh my gosh, that's just really complex. But then when I speak in front of audience, I often ask the question and a few hands will go up and say, I know what that is. Well, that's because those people are familiar with the language. Now, is it complex? Is it simple? How do I know whether it's simple or familiar? Well, as it turns out, that word means simple, uncomplicated, casual, and common. Of course, you may ask me, how do I know? Oh, very simple. I Googled for it. But the point really is that it is something might look complex to us because we are not familiar with it. Let's take a really simple problem. So the simple problem I'm taking is the following. Given a bunch of names, our problem is get comma separated names of length 4 in uppercase. Hey, that's a fairly simple problem, isn't it? It's not a rocket science. How do you solve that particular problem? Let's use a familiar approach. So we could say for int I equal to 0, I less than, and you say, oh my gosh, that's a lot of work, Venkat. We can make it a little bit easier. Let's say string name coming from names. Hey, that's great. I can go through all the names in this collection, and I can output name.to uppercase right there as I loop through it. That's printing all the names in uppercase. But remember, the problem says names of length 4. So name.length is equal to 4, then print it, not otherwise. That looks reasonable as well, isn't it? But the problem again says those should be comma separated. So let's go ahead and put a nice little comma in there. But of course, the problem also says they got to be on the same line. Obviously, it should be a string we are creating to be on the same line, and we do this. But did you notice that at the very end, there is a silly comma? Have you ever seen this problem? All the time, isn't it? And you sit there and think about, how do I get rid of that comma? And you tell yourselves, maybe I'll create the string and I will strip it out of the string. Oh, darn it, the string is immutable. Or maybe we could create a string builder and put stuff into it. But how do I tell the comma not to be there in the last line? You're scratching your head for a few minutes and your colleague says, hey, there's a very simple way to solve the problem. And you're like, really? What is a simple way? And they say, all you have to do is not put the comma if it's the last element. Well, but how do I know it's the last element? And they say, oh, no problem. Do I equal to 0, I less than names dot, is it size? Is it count? Is it length? Well, all of a sudden, notice the solution doesn't seem to be that simple. Well, it's a simple problem. It's a familiar solution, but definitely, I would argue, it is not a simple solution. So oftentimes, we take simple problems, we may apply familiar solutions to it, but doesn't mean it's a simple solution. But as it turns out, there's somewhat of an unfamiliar solution for a lot of people, but it's actually simple. So one thing you could do potentially is we could bring in the collectors into this case from Java. And what we could do in here is we can say, for example, output, but take all the names given to us. And we can do a stream on it. We can do a filter where we take a name and we say name of length is equal to 4. We can perform a transformation and say string to uppercase and transform the code to the name to the uppercase. And we could do a collect on it. And of course, we can simply say joining using a comma, and that becomes so really simple for us to be able to implement, as you can see in this particular case, without actually a lot of effort to write the code. So as you can see right there, not only did we get the result we want, there's no silly comma in the end as well. Now, of course, what did joining do? Joining was really smart enough to express the idea where we want to collect all this data into a string, but separated by the delimiter of a comma, and life becomes really easy, as you can see. So that's an example of a code which is simple compared to a code that was familiar that we saw. So don't confuse the word familiar with the word simple. So when I work with developers, when they say something is complex, I often ask them, hey, is that something you are not familiar with? Or is it really simple versus complex? And asking that question explicitly can help us to really understand what we are dealing with and remove our biases that we often carry as humans, which is pretty natural when it comes to looking at something really new. So a lot of us are familiar with imperative style, but the declarative style of programming is a lot simpler, and functional programming is declarative. That's one of the reasons why I like functional programming, is not because it's fanciful, it's because it's simpler compared to imperative style of programming. Now, simple has fewer moving parts in it. And that's one of the nice things about programming this way. This reminds me of a beautiful words by Michael Feathers. And I'm going to paraphrase his words, but I think this is a really, really good way to think about it, if you will. So what did Michael Feathers say? Well, Michael Feathers said something that absolutely intrigues me. And again, these are the words of Michael Feathers. And Michael Feathers, Feathers, if I know how to type Feathers, there we go. And Michael Feathers said the following. He said, and again, I'm paraphrasing the words. He said, in object-oriented programming, we encapsulate the moving parts. In functional programming, we eliminate the moving parts, he said. What a beautiful way of thinking about it, isn't it? So in object-oriented programming, we encapsulate the moving parts. In functional programming, we eliminate the moving parts. That's a really nice way to think about it, because what we are saying here is, if you have a lot of moving parts in the code, it increases the cost of development, it increases error, it makes concurrency really hard, and there are so many other problems that come about. So what does OOP do? It tries to lock them in and say, let's encapsulate the moving parts. Functional programming says, get rid of it, because what you don't have will not cause the problems for you. That's a really nice way to think about it. And of course, simple, I mentioned, is not clever. I mentioned that simple is not necessarily familiar, but simple is not over-engineered. How many times have we created code that nobody can figure out what the code is doing? And it's so complex, but why did programmers do it? Because we want to create something that is extensible. That's one of the holy grails of software development, isn't it? You know, there was a gentleman called Rube Goldberg, and he really wrote about making things simple into something very complex. And those are called as Rube Goldberg machines. Now, my children have gone through school and they're growing into adults, but when they were in school, the schools would ask them to work on a project every year. And the project was to create their own version of Rube Goldberg machines. And they would create something very, very complex, like one of the Goldberg machines where there's a water that splashes on this person who pulls that umbrella, which then pulls that line of thread, which then moves that, and eventually it results in a back scratcher for that particular person. Now, that looks really weird, but every one of us have created code like this in the past, isn't it? I remember one day looking at a piece of code when a programmer had written about 200 lines of code to take a data from a database and convert into XML, and then sends that XML document to another function. And that function takes 200 lines of code to parse the XML and put the data back into the database after a small transformation. And I'm sitting there thinking, wait a minute, we went from database to XML to XML to database. And I was kind of pain struck. I called the developer and said, excuse me, can you tell me what's going on here? And he looked at me and said, isn't that cool? I said, no, it doesn't look cool to me. Why are we going from data to XML and XML to data? And he said, Venkat, you need to have a vision. I said, what kind of vision should I have? He said, think of extensibility. I said, I don't understand. What does extensibility mean over here? He said, think of the future. I said, I'm trying to help me out here. What do you mean? He said, the data can go from here to anywhere. And the data can come from anywhere to here. And I said, okay, let me understand this. In the application we're developing, where is the data? He said, it's here in the database. And in this particular function, where should it go? He said, here in the database. So I said, okay, it needs to go from here to here. So why are we talking about going anywhere and coming from anywhere? He just shook his head and said, you really need to have a vision. And while he was doing it, I fiddled with my phone. And his phone rang. He said, hello. I said, hello. He said, who is this? I said, how are you doing? And he said, is that you, Venkat? I said, yes. And he said, I don't understand. Why are you calling me on the phone when you're right in front of me? I said, you need to have a vision. I could be anywhere talking to you right now, so we should never talk in person anymore. We should always talk in the phone. Well, that doesn't make any sense, isn't it? Well, the point really is we tend to take this extensibility to the extreme, but we forget to think about what are we really solving? What is the business need, and be able to solve the real business needs, not some hypothetical extensibility. Well, the next thing is simple is not terse. Now, this is another thing to consider when it comes to simplicity, not clever, not necessarily familiar, not over-engineered, but not terse. Well, I came across this code. This is actually true code from a project I was working on for a client. And they opened some files and went on. I said, excuse me, can you go back to the other file you showed me? And the developer went back there. I said, my goodness, is it okay if I take a photo of it? And the developer said, well, if you promise to not tell anyone where this code came from. I said, absolutely, I will never reveal the name of the company. And they said, okay, take a photo. So what did I take a photo of? Oh, not that line. The line I wanted to take a photo was the line below that line. In all honesty, this is what I found. It said, God help me, I have no idea what this means. Can you imagine developers leaving a comment like that in production code because they don't have a clue what those variables mean? Oh, if you're curious what this application is, this application actually controls refineries in chemical engineering. And imagine one of the chemical refineries blowing up because you got things wrong. And when you're dealing with complexity, this is called a self-inflicted wound. We cause this on ourselves by giving really bad names. That's an example of terseness. So I want you to think about two words which are really useful to think about. So what are those two words? The two words I want you to think about are the words concise, if you will, and the word versus the word terse. Now, what is the difference? Both concise and terse are really small, but concise is small and nice. Terse is small and waiting to hurt you when you least expect. I want the code to be concise, not to be terse in general. So look at some examples of this. When you look at this code right there, this is an example of a verbose piece of test. We all have written something like this, isn't it? So you have a rod cutter set price, then you have a try, when you have a max profit, you have a fail, you have a catch, you have an assert. What are we trying to do in this test? We are trying to tell that the max profit should throw an exception. Now, of course, you probably know there is an alternative way to write this. And that is, we could say, test expected rod cutter class dot expression dot class, and then set price and max profit. I'm not a fan of this at all. Part of the reason I'm not a fan of this is terse and not concise. If the set price were to blow up, this test may fail, but may pass rather, for the wrong reason. So I want the test to never pass for the wrong reasons. Well, how do I write it then? I would go back and write it in the verbose mode if that's the only option I have, or I may choose a different solution like an assert throws. This to me is concise versus terse versus verbose. And I always want to look for not a terse solution, but a concise solution as well. And that is something we need to really focus on. So don't confuse terse with concise and simple. We want to make things concise as much as we can. Well, as Tony Hirsch said in a beautiful way, he said there are two ways of constructing a software design. One way is to make it so simple that there are no obvious deficiencies, and the other is to make it so complicated that there are no obvious deficiencies, he said. So one is there's no deficiencies obviously, and the other one is where we don't even know what the deficiencies are. Well, he talked about what is not simple, and would be unfair to end this talk without actually maybe identifying a few things that are simple. So maybe we can make an effort to think about a few things that are simple. But I want to pause and see if there are any questions or comments, thoughts, anything you think about. If you have run into something, you can put that on the Q&A. You can say, yep, I've seen that one before. You can say LOL if you find a joke funny, especially if you don't find it funny. That's a good feedback as well. You can put your questions there. You can put your comments there. Try to make it as interactive as you can. So I'll just pause and see if there are any questions or comments. Jay, have you seen any questions or comments come through?
No, there is not. So the attendee can put the comments. So we'll be trying to reply that.
Awesome. Well, let's hope that we'll have some questions or comments. Otherwise, I kind of feel that you and I are talking to each other and there's nobody actually around. So I encourage people to post comments, post thoughts. If you find something interesting, or if you find something that you have seen, put a note saying that you've seen something like that. That's a good feedback to have as well. Or if you have not seen something or you don't understand something, post a question. So both questions and comments are really useful. Yeah, thank you very much for that comment. So essentially what we are talking about is things that we often identify, things that are not really simple, but what about things that are simple? How do we really focus on that? Well, the first one is simple keeps us focused. If you ask me, what is one thing that's the most valuable in the world today? I say today because we are constantly distracted by, Twitter and Facebook and Instagram and TikTok and what have you. How do we really stay focused at what we do? And attention span is one of the biggest challenges in the world today. When I'm working with a piece of code, what if the code can keep me focused to solve the problem that I'm working with? So I'm going to say simple keeps us focused. So let's think about an example of staying focused. And let's say for a minute that you and I are working on a piece of code, and I'm not exactly sure how do we write this particular code, what function to call, what API to call. We are not really sure about it. So as a result, the question is, what do? We typically say we want to quickly search for an answer. Well, let's do a search, right? Maybe I want to know how to call this particular function. What kind of search can I make? So let's do a quick search if you don't mind. So let's bring up the browser to perform a search. So when I bring up the browser, hey, look at that. I have a Yahoo search page that popped up right there. Oh, wait a minute. Michelle responds to Rudy Giuliani, a crude story. This Giuliani is a funny character in the U.S. politics. I've known him, in terms of the presence for the past about 25 years. It's pretty interesting to see the transition. What else do we have? Sustainable living. That's pretty interesting to watch. And, let's see what else is kind of interesting over here. Oh, something about Dave Chappell right there. Oh, wow, wow. Really interesting stories over there. A wealthy Florida couple to give different accounts of violent confrontation. Oh, my goodness, that looks pretty interesting to read. Well, just what happened, right? I totally forgot about really the API I wanted to search. And now I am kind of flipping through all these interesting news that I see. Not a good way to spend the time, isn't it? Let's quit that if you don't mind. So let's exit that Yahoo search. Let's try one more time. Oh, that is a Bing search. Whoa, what a beautiful light over there. Does anyone know where this is from? It's overlooking Doro. Wow, I'm kind of curious. I want to know where that is. I'm going to kind of search for that as well. And a few interesting things in the bottom. Well, guess what happened? Not as disruptive as the previous one was, but still, it didn't quite give me what I was expecting. Let me try this one more time in here. Let's go ahead and run the code again. And oh, wait a minute, there's a Google search. And what does it tell me? It says, why are you here? Oh, I'm here to search. And Google is saying, and what are you waiting for? Go do the search after all. And I'm going to go ahead and do the search for this right here as the joining and look for it. Well, the question really is, in this case, when you're typing all those, what does it do? It tells you, hey, you are here to search. Now, don't, get me wrong. Right behind that button, there is an enormously complex algorithm and servers and infrastructure and cloud and AI, but they did not bring that complexity to our face. Instead, they simply said, hey, you are here to search, search. So I'm going to ask you the question, how many of us use Google compared to Bing, compared to Yahoo search, for example? Well, there's a reason why most of us use Google. And the reason is we care about our time. We value our time and we value our focus. And that's one of the reasons why we use the tool. And but at the same time, I want you to think about one thing if you don't mind. And that is, imagine the day when the developer wrote that UI and goes to the boss and says, hey, boss, I've created the UI. And the boss says, show it to me. And the developer shows that page. And the boss is like, are you kidding me? What is there in here? Well, I know you're going to ask me this question. That's why I added, I'm feeling lucky. Well, you should feel lucky, right, to have this job. Well, the point is, when you and I are at work, how much pressure do we face from other people to make things violent and complex? As Einstein said, takes a touch of genius and a courage to stand up against complexity. I would say the developers who wrote this, the UI expert, the UX experts who wrote this, they have exhibited courage to say, no, I'm going to keep the focus. Now, you may remember a long time ago, well, I'd say long time ago, maybe 6-7 years ago, I don't remember. One day you went to Google search and it started posting pictures on the Google page. I don't know if you remember that day. And there was a hue and cry of people saying, oh my gosh, Google has done a terrible thing. And they removed it within 24 hours and they made it plain and simple like this. And part of the reason they did that was they were trying to creep into giving that pressure to put more things on the page versus really keeping the focus of people using the product. So the point I'm really making here is that we really want to keep the focus of the people. That is part of simplicity. As a beautiful phrase by Antoine de Saint Exupéry, he said, perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. What a beautiful quote right there, if you think about it, right? So perfection is achieved not when there is nothing to add, but when there is nothing to take away. Isn't that what we try to do in refactoring constantly, if you will? So we try to constantly remove things and make things minimalistic and smaller. And that is one of the things we strive for as much as we can. And that is something we need to work towards, making things simple. So simple eliminates accidental complexity and hides inherent complexity. And that is exactly what we should be doing as designers, is constantly work towards eliminating the accidental complexity so we can focus on the genuine inherent complexity from the domain of the application we are dealing with. Well, the next thing is simple fails less. Now, when it comes to talking about simple fails less, you probably have seen this question in interviews. They often ask you the question, why is the cover of the manhole circle in shape? And I'm sure you all thought of answers to that question earlier, isn't it? And you probably said, well, it's really because that's a circle because, well, why? Well, we could come up with different answers to that question. Well, you may say part of the reason why it actually is circular is, if you look at this in this case, it fits in really nicely and it won't fall inside. Imagine the plight of the people who have to do that work every single day. They have gone down that hole, did the work, they come out, and the last person who comes out has to roll this over. And while rolling it over, it falls into the hole. Nothing could be worse than that, isn't it? So the beauty is the circle is so nicely going to sit on top, it won't fall in. Now, of course, let me ask you this question genuinely, because you know this experience working in the corporate world, isn't it? If you're given a request for proposal and they tell you design something that doesn't fall in, would you design that? Or can you make more money by designing something more complex like so? It turns out every single one of these share the same characteristics as well. Those will not fall into. So if unlike as much as the circle won't fall into the hole, these will not fall into the hole as well if those are designed for that particular shape. Now, then the question is really the reason why the manhole cover is a circle? Well, it turns out there's one more reason for it. And the reason is, if you come up with all these different shapes, one of the questions you ask is, what direction do I put that into? Well, guess what? The circle is in the right direction all the time. There's no wrong direction for a circle. Just roll that in and you're done. That's simplicity right there. So simplicity really comes to picture with every single design that we look at. So simple is easier to understand and is easier to work with. But more important, a simple also has to fail less. Well, here's one quick example about simplicity, if you will. Let's say I want to compute prime numbers. So I say is divisible by, tells me whether a number is divisible by something or not. Is prime number will tell me if a number is prime or not. I can take this further and say primes starting with a number, a list of integer. If a number is a prime, then take that number and concatenate it with all the numbers you have so far. Otherwise, skip it and go to the next number. Well, it looks like a simple solution, but unfortunately, this will not work. Why wouldn't this work? Because it'll have a Stack Overflow error, isn't it? Well, but how do I solve the problem in a way it is simple to represent? It turns out I can learn a few different tools and I can try to answer that question. So next prime returns to me the prime number that is the next prime number, or simply calls the next prime right after that. But you may notice that's a tail call optimized call, and prime simply says, I'm going to take a stream of integers and I'm going to look for a number of values you expect, and I'm going to collect them into a list and return it. It turns out that code actually works, and you're able to get a list of all the prime numbers, starting with the number, but how many ever you want. Well, this takes us to what's called infinite streams or an infinite collection that we can work with. So by learning a set of unfamiliar tools, we can move towards simplicity. But simple is not only this. It is also where the simple actually is elegant. And Mirza has a beautiful point. Mirza says, to write simple and clean code, it takes skill and time. Oh, totally. You just wrote the talk for me, which is exactly where I'm moving towards in about 5 minutes from now, Mirza. So thank you for that. Absolutely. So simple is elegant. Well, what is elegance after all? Can you imagine why this is considered to be the most, if you will, the most popular painting in the world, right? So why is that considered to be the most popular painting in the world? It is because it is absolutely simple. Just look at that picture. There is nothing in there that is not necessary, that is extraneous, that is overbearing, that is polluting, that is corrupting. No jewelry, no distractions, no ornaments. What is there? Absolutely nothing to distract. This is why we call this painter the genius. The painter is a genius because the painter brought natural concepts in here rather than distracting with all the other unnecessary things. That is one of the reasons why this is so beautiful, if you will. So as a result, we can ask the question, how do we really make this simple? Well, as it turns out, I'm going to talk about one architect's dilemma here to talk about this. If you get a chance to go to downtown Boston, I recommend you take a look at it. A few years ago, I was in Boston with my family, and we were walking through the downtown area. And what came was this particular beautiful church. And this is the Trinity Church. And you may say, yeah, it's a church. What's the big deal about this, Venkat? Well, as it turns out, as I was walking through the downtown area, I came across this particular church, and I was quite intrigued, if you will, by this church, not because this church is any special, but it's because of the building that was next to this particular church. And what I came across right at that point was a reflection of this church on that particular building. It was so mesmerizing. I stood there for a long time staring at it. And then I came back and investigated a little bit more into it. And I found that when they wanted to build this building, the John Hancock building, they didn't get permission to build it. The city did not approve it because they did not want to build a tall building next to a beautiful church. But the architect made a challenge and said, I'm going to build it here, and when I'm done, the church is going to look even more beautiful. And he placed the building in an angle with reflective mirrors and so beautiful reflection. I was like, wow. And I stood there long enough that my family threatened to call the cops if I don't move after all. The camera didn't do a good job, in my opinion, compared to I remember this place saying, oh my goodness, it's so beautiful. Now, to me, one of the reasons I really appreciated this was the simplicity of the design, how genuinely simple this is in bringing out an architectural element that really thrilled me in what I saw. But to Mirza's point earlier, simple has to evolve. You cannot just make something simple in day one. Mirza said it takes skill and takes time. Absolutely. Simple has to take time to evolve. It's not something you can do overnight. It is something that takes a long time to get good at. Now, as Richard Feynman said, if you cannot explain something to a first-year student, then you haven't really understood it. This is so important to keep in mind. You know, when I create something, I always try to explain it. If I have difficulty explaining it, what that really means is two things to me. One is I haven't really understood it, but also it's probably way too complex than it should really be. And I remember that personal experience, but I'll come back to that in a minute. Well, as Occam's razor says, if you have two equally likable solutions to a problem, then choose the one that is the simplest of the two. And we want to strive to create simplicity. Well, I came across this experience when I was writing the Functional Programming in Java book. My book was published about the same day when Java 8 was published, but I was very eager to bring some new ideas that were in Java, but also push the boundaries of a few things. And in the middle of writing the book, I had an idea to do something that would be really nice to have. So for example, if you have a factorial function where the factorial returns a number, if it is 1, or it returns a number times factorial of number minus 1, we all know what that is, a simple recursion. Now in the main, I call the factorial with a large value. Notice we got a Stack Overflow error. What a sad story, isn't it? So what if I want to really use recursion? Well, it doesn't work really well with such recursion for large numbers. But I have taken the time over the years to read about a few things, including the structure and interpretation of computer programs. What a beautiful book. But that book talks about different things. And one of the things they talk about in that book is a difference between what they call as procedure versus process they talk about. So what is the procedure, what is process? So procedure is what we write when you write the code. Process is what executes. So in general, there is a transformation from what we write to what actually executes. So you can write a recursive procedure, if you will, procedure, and then run as a recursive process. Well, that's exactly what we did in here. We wrote a recursive procedure. It ran as a recursive process. And as a result, it ran into trouble when the size was really big. On the other hand, you can write something as a iterative procedure, and you can run it as an iterative process as well. So that is another option. This is where you write a loop and you run it as a loop. But a third option that you have is to write it as a recursive procedure, if you will. So in this case, I want to write it as a recursive procedure, but then you run it as a iterative process. How would that work? Well, this is where compiler techniques come in. The smart compiler can take your recursion, but then change it into an iteration behind the scenes. Well, guess what? Languages like Scala do that. Languages like Clojure and Haskell and Erlang do that. Well, languages like Groovy has libraries that attempt to do that as well. When I've read all these and experienced those things, I said to myself naively, hey, I should be able to do that in Java. Well, as you know, Java does not have tail call optimization as of today. But I really wanted to show tail call optimization in Java. So what did I do? I created an example where I wrote a factorial to return a tail call object, if you will. And if it is number is 1, it returns a done, otherwise returns a call to the next function it would evaluate eventually. Then, of course, I call that function from there. And you can ask me, Venkat, how much time did it take for you to come up with this idea? It took me 2 days of my life, completely wasted. And I spent 2 days creating the solution. And after 10 more hours of effort, I came up with this, where I said tail call returns the next call, and the done is saying return a tail call is completed is true, returned value is value, tail call returns a null, and then I wrote the function eventually for the invoke. If you notice what I do in the invoke function, I said is complete, and I get the current, while not call completed, current equal to current dot apply, and then I call the next one, and I go through iteration to do this. Now here is the problem. This code worked. 2 days of my life wasted. I had a code that works. And I looked at this code and I said to myself, uh-oh, what's the problem? Look at this line right there. Current equal to current dot apply. What is that? You notice very quickly what that is. That is mutability right there, isn't it? In functional programming, we recommend to honor immutability. And remember, I was writing a book on functional programming in Java. Until the previous page in the book, I kept telling the readers, please avoid mutability, please avoid mutability, please avoid mutability. And what am I doing here? Mutating. And I was sitting there scratching my head, oops, what do I do? And I struggled with it. And then I came up with a solution, which I thought was a reasonable solution. And the solution was to put a footnote in the book. Dear reader, do you notice I'm using mutability on that line? I leave it as an exercise for you to turn this code into using immutability. You know what? That would have worked 30 years ago, because as an author, you can write a book and you can publish it and never have to face the readers directly. Today, we live in the world of Twitters and Facebooks and what have you. And immediately somebody would tweet back and saying, oh, really? Why don't you show me a solution, huh? Then I thought about it for a while. I came up with the second best solution. I said, footnote, dear reader, do you notice I'm using mutability on that line? Well, honor immutability where possible. And I felt really bad. That was not a good solution either. And I then came to a grim realization. And sometimes that's the hardest one to do, isn't it? And the realization I came up with was, my code simply sucks. It's really terrible code I've written. It's complex. There's got to be a better way. So I abandoned that code for a few days, went off to do other things. And then a few days later, I was on the treadmill jogging. And in the middle of my jogging, my thought was slowly going back and thinking about this problem. And suddenly I realized, oh my goodness, there was a simple solution I did not even realize. I jumped out of the treadmill, ran across the floors of my house, and got to the computer with my children asking, Dad, are you okay? I'm like, I'm fine, but I think I have a solution. And within 10 minutes, I found the solution. And the solution was to rewrite the invoke function to use an infinite stream. So streams.iterate, and what did I do in here? The streams.iterate, and of course in this case, by the way, this would be stream.iterate in today's word. Stream.iterate, filter, tail call is complete, find first, get result. And you may say, gosh, how does this work? The answer is lazy evaluation. So lazy evaluation with infinite streams removed the burden of mutability in the code. But not only that, the code got simplified so much to explain how that's actually working. It was not only easy to work with, it was easy to explain as well. So if we find something is hard to explain, it's either that we haven't understood it or it's really complex and we have to simplify it before trying to explain it. As Einstein said, everything should be made as simple as possible, but not any simpler. And so we should really ask the question, how can we make this simpler? But the question I want to ask is it simple or is it still complex? How do you know? Well, is what I created simple or is it really complex? How many times have you seen this? You create something simple. A colleague of yours comes and sits next to you and says, that's complex. You're like, really? And you have a discussion and now you have something simpler than you started with. So my question is a solution simple or can it be simpler? And there's no good answer to this question. I often create something. I show it to a colleague and say, what do you think? And they either say that's good or they critique it and we make it simpler after that. I'm going to say simplicity is the Schrodinger's cat because a solution is both simple and complex at the same time. It is simple to my eyes, but it can become simpler when I get the input from a colleague who can look at the code and help me to make it simpler, look at a solution and help me make it simpler. Now, there are two reasons why I care about simplicity. Simple makes things easy, but it certainly is not easy to make things simple. The result is beautiful, but the effort and the journey is arduous. It takes a lot of effort. But there are two reasons why I really want to make things simple. The first reason is to attack that particular problem and make it simple, sure. But another more important reason is every attempt I make to make something simple, I become stronger. I'm able to think about how to make things simple. And as Mirza said earlier, I'm developing my skills along the way. So making things simple is not only to make that thing simple, but also to make ourselves stronger in developing skills so we can make things simple. Now, in my own journey, I've been programming for about 35 years now. When I started programming versus what I do today, it's a lot easier for me today than it was before, not because I'm any smarter, but it's because of the time and effort I've put in and the skill I've developed over time. I'm able to solve the problems a little bit more easily, and I'm hoping it'll get better as I gain more experience over time. That's exactly what we do, is we solve the problems at hand, but we also genuinely develop skills to solve that problem as well. As Da Vinci said, simplicity is the ultimate sophistication. And that's one of the reasons why I think we should really strive to make things really simple. I hope that was useful. Thank you so much for taking the time to join. I'll be delighted to listen to your questions or hear your comments. I want to thank Jay and everyone else who were involved for taking the time to organize this. And I also want to thank everyone who took the time to join as well. Thank you.
Thank you, Venkat sir. So we have a question by Mirza. So there is some random question. Just on the session, you told that just try to be more interactive. So there are some questions. So I saw people writing code instead of using libraries and focus on business value.
Yeah, that's a bad thing because that leads to more complexity in the long run. Also, we introduce bugs in doing so, and the code becomes enormously complex. There's a balance here we have to strike. Don't use a library which you don't really need, but don't build something that's already there. So one of the phrases I often use is, don't buy or download what you don't want, and don't build what you can buy or download. I'm going to write that down because that's a really important distinction to make. And that is, do not buy what you do not need, and do not build what you can buy. So that is something, right? And buy, and of course, download is something to really bring about as well. So do not buy or download what you do not need, and do not build what you can buy or download. So both of those are really important, I think.
Okay, thank you. So one more question, how to keep ourselves familiar with so many versions coming out frequently? So in .NET, Java, there are many versions going on and on. So how to be familiar on that?
So one of the interesting things about learning in general and being familiar in general, there's a lot of similarity between the mental muscle and the physical muscle. You know, if I don't exercise, if I don't jog, if I don't keep myself active, I become really hard to, go out and exercise, go out and have fun. And my mobility really decreases over time. So what do? We physically exercise, we keep ourselves active. Same thing with the mind as well. When we, learning becomes easy when we learn continuously. So that is one of the things to really keep in mind. What if we devote 30 minutes every single day to learn something different, to learn something new? So one of the best ways, two ways to do it. One is devote 30 minutes a day to learning, and also pair with others. This is not being done enough in our field. The more we pair with others, it accelerates our learning because you're leveraging the power of multiple people together. I don't know something, but I sit with you, Jay, and as we are working together, you say, hey, have you used this other one? I'm like, no, Jay, I don't know what that is. Now I've started to learn something I did not know before. So pairing is really, really a great way to accelerate that learning as well.
Okay, thank you. So there is to write simple code and clean code. It takes skills and time. Yeah, absolutely. So without skill and time, no one can able to code better. And yeah, one question is that came from the outside. So what is your suggestion to the programmers who is facing the imposter syndrome?
Oh, I never have imposter syndrome because I know that I don't know a lot of stuff. I don't agree with the word imposter syndrome at all. Well, imposter syndrome tells me that somehow I am special and I need to really question that. No, I'm not special. I am as much as a developer as anybody else is. So why should we have an imposter syndrome? I would even say imposter syndrome goes back to personal ego. I think there are more important things to spend our time and effort on than on ourselves to have an imposter syndrome. I never have imposter syndrome because it's not worth my time to spend my time thinking about myself and the consequences. There is so much to learn. There is so much to genuinely understand. And I'm just yet another person in this world as much as anybody else is. So when I sit with a developer, they have the same problems I have. They have the same struggles as I have. And the only difference is I'm a little bit of a loud mouth than the rest of the people around me may be. So that doesn't cause me to have imposter syndrome in any way. I think we should just focus on learning and getting better than trying to say to ourselves somehow that we are special and then we start questioning that. No, I never have imposter syndrome for that reason.
Okay, thank you. Yeah, and one more thing. So do the programmer should be a leader? So
Uh,
yeah.
Everybody should be a leader, but we also must be a follower as well. I follow a lot. I follow the suggestions of my family, my parents, my cousins, my uncles, my aunts, my colleagues, the people who are in the field that have done a good job. I follow everybody, but I also leading is important too. You lead by example. You want to show what you can do in moral values, in your work ethics, in professionalism. We have to stand up to be a leader. Leader is not a person who is appointed. Leadership is not a position. Leadership is how we behave professionally with integrity every moment of a day. Leadership is showing up on time to a meeting. Leadership is developing code with quality. Leadership is being kind to that person to be receptive to their ideas. So absolutely, leadership is there, but a leader cannot be a leader without following. So we have to be as much as a good followers to be good leaders as well.
Okay, yeah, pretty nice one. Thank you. So this is basically the individual who are in the internship level, who are freshers. They should be leader while developing their career in the IT. So we have one question. What do you think about a project? About a project with a lots of abstraction?
It is most likely leading towards complexity. This is one of the things we have to be genuinely careful about. Is Ralph Johnson, one of the co-authors of the Design Patterns book, he nicely said once. He said we create interfaces, we create hierarchy, we create abstraction, we create all of that with the genuine desire to make the system extensible. But in doing so, we make the system hard to extend over time. So one of the things I often recommend in software design is come up with all these abstractions in your strategic design, but don't introduce them in the tactical design and bring them in only on demand when you clearly can see a reason, a benefit to bring them in. So we really have to be careful. Ken Beck talks about what's called a minimalistic design. And that parsimony or a minimalistic design or fewest elements is something we should definitely favor. Now, obviously, the question is, if it's minimalistic, what if we create a ball of mud? Well, Ken Beck also talks about testability. So there's a balance here between, for things to be testable, it's got to be modular. For things to be minimalistic, you got to have fewer modules. So there's a nice balance between the two. So start writing test and move towards minimalistic design is a good solution.
Okay, thank you. So the next question is that which book would you recommend to learn Java for an experienced developer?
I have no recommendations for books. I never recommend books because I recommend reading 6 or 7 books, not just one. So don't ever look for one solution. Learning has to be continuous. So learn from as many books as you are able to. But also more important, if you really want to get a really good in-depth knowledge, my formula is 1 hour of reading and 10 hours of programming. And so if you pick up a book, do so great, but just don't plow through that book. Read for an hour, but then spend 10 hours coding those concepts, and then come back and start reading further. And you may say, hey, I've already experienced that in my experimentation. That's great. You get a different perspective the author has to offer on that end, and you might absorb a lot more doing that too. So just not read a book, but practice while you're reading. That is extremely important.
Okay, thank you. So as our topic is about the art of simplicity in programming, right? And the programming, there are lots of programming languages, right? So what would you recommend? Which programming language should we go? Should we go with a Java, .NET, Python, Ruby, and Rails, and all other stuffs? So for new freshers.
So my recommendation is don't learn a language. Instead, learn 2 separate things. And one is learn problem solving. So this is what we do over and over and over is learn problem solving. And we are not hired to program. We are hired to solve problems. So learn problem solving. Second is don't learn a language. Instead, learn different paradigms. So in other words, when you look at a language, don't look at like, I want to learn a language. Instead, you ask the question, what are the programming paradigms that are out there? You have structured programming, object-oriented programming, procedural, functional, logic programming, and so on. You want to get a fairly good flavor of these different paradigms. Languages may have multiple paradigms in them potentially, but you also want to spend enough time on a language that deeply favors one paradigm because it changes your thinking to on that paradigm in how you approach problem solving using that paradigm. So if somebody says, I want to learn one language or 2 languages, they're putting themselves at a great disadvantage. There was a time in my life when I knew only one language. Now I program in about 15 different languages. I'm not good in any one of them, but that's okay. But I can think differently and in a broader way, and I can reach to solutions in a different way than I could before. So the worst thing a developer can do is to convince themselves that there is somehow one language they should really take the time to learn. Instead, take the time to learn different paradigms and then keep learning. You want to learn different languages to get deeper into the paradigms of thinking, and that really reduces the time to learn as you move forward in the future as well.
Okay, thank you. But in this scenario, lots of company in the recruitment process they require Java developer, .NET developer, right, or others type of developer. But if we are going with this approach, as you had said, suppose a guy doesn't know the .NET, but he knows about the paradigm of different languages, so he will be able to do that job.
So they're not hiring you because you know something. They're hiring you because you can solve their problems, isn't it? So if a company says, I'm going to hire you because you know this, I would say that's not a company I want to go work in, because a good company wants to look at my ability to solve problems. I'll give you an example of this. I was interviewing a candidate, and I sit down and I said, let's talk about programming. Let's talk about your strengths in programming. And the person said, yeah, I've been programming for 10 years. I'm like, this is great. Let's talk about C Sharp. And let's talk about a few things in C Sharp. And the programmer said, you know what, I don't know C Sharp really well. I said, okay, no problem. Tell me what other things you have done. Oh, I've done C++. I said, no problem. Let's talk about C++. He said, I don't know C++ that well. And I said, listen, you tell me what you are really good at. And I'm going to come back and talk about that to you, because my goal is to know how deep you go into things you know about. Because if you can show that to me, you're showing that you are capable of learning really well in things I care about. So if somebody has a marginal area, they haven't really taken the time to think critically. They haven't understood why certain things work in a certain way and when to use one solution versus another. The fact that they know one language is of no use to me. Why? Because I give them a problem and they end up solving the problem really poorly using the language they know. So it's really important it's a two-way street. Not only should a company hire a good candidate, it's also important for a candidate to know that it's a good company to work with as well. So if the company is not recruiting properly, why would you want to go work over there? You want to go work in a company where they know what the right things are as well. So look beyond just the, passing the interview. You're not a candidate whose job is to pass interviews. It's your career, how important that is. You need to pay attention to that as well.
Okay, quite nice one. So yeah, we'll be taking the last question and we'll be wrapping the QA session. So there is any example how to peer in learning or coding as a peer programming?
Peering, find a colleague at work, find a colleague in the community, your local community, right? You have a Java user group, you have a techWebinar user group, and you say, hey, I want to pair with somebody and to solve this particular problem. At work, you may have a good, genuine colleague who is as eager to learn and get better as you are. And you tell them, hey, should we start pairing with each other? So pairing really requires the right attitude, the attitude to share what you know and the attitude to learn from others' perspective as well. So open up for pairing, and the more you approach other people to pair, the more you will find people willing and interested in pairing as well. So find a colleague, find a person in the community, find a person at work, find a person in the user group, whomever you can come across. Find the person who has got the same interest in learning and improving, and start pairing with them.
Okay, thank you, Venkat. So with this, thank you all. Thank you for attending Tech Webinar Nepal Series 27. It was a wonderful and grateful session. So many, I myself has learned lots of things about art of simplicity in programming, and hope attendees has also got lots of information about this. So thank you to our supporters, Microsoft, Living with ICT, and Tech Patro, and as well as to our respected speaker, Venkat. Thank you for your time, and thank you for your invitation. Hopefully you will visit Nepal next year or maybe some more year. So do come to Nepal country, see here the lots of beautiful places. So warm welcome. And with this, wrapping the session, thank you all for joining Tech Webinar Nepal Series 27. We will see you all in Tech Webinar Nepal Series 28. Thank you all. Good night. Have a nice day. Thank you. Bye.